functions in high school, you should know that if you have sine hyperbolic of x, it is the same as exponential x minus x over 2. And cos hyperbolic of x is the same as exponential x plus exponential minus x over 2. So if you're told to differentiate, let's say sine is the same as differentiating this part. So like d dx of sinh x, we already know the answer, it's cos x, yeah? But how do we get the cos x? It is d dx of this side, which is exponential x, I'll write over 2 minus exponential x over 2. So this is the same as me differentiating this with respect to x and me differentiating this with respect to x. And that will give me a half. The derivative of exponential x is exponential x minus a half. The derivative of exponential minus x is minus exponential minus x, if you remember from the table that I gave you on the differential coefficients. So putting this together, this gives me a half exponential x minus will give me plus a half exponential minus x. Putting these two under the same LCM, which is 2, it will give me exponential x plus exponential minus x, which is equal to what? As you can see here, which is equal to cos x. And from the tables, we saw that cos x when differentiated, we get, sorry, sine hyperbolic x when differentiated, we get cos hyperbolic x and vice versa. So that's how we go about differentiating the hyperbolic forms. And let's say we have something like, maybe we want to differentiate something like tan hyperbolic. Now d dx, let's look at this example number 2. What is d dx of tan hyperbolic? d dx of tan hyperbolic x. What is d dx of tan hyperbolic x? So d dx of tan hyperbolic x. Now tan hyperbolic x can be expressed as sine hyperbolic x over cos hyperbolic x. Okay, so d dx of this is the same as me differentiating using the quotient rule. Let this be u and let this be v. So we will have u prime v minus v prime u, all this divided by v squared. So what is the derivative of sinh x? From the table, if you're differentiating this, you will get cos x multiplied with v, which is another cos x, minus v prime. If you differentiate cos x from the table, it was giving us sinh x, multiplied with u, which is another sinh x. All this divided by v squared. So v squared, that is cos x squared. Guys, from hyperbolic identities, I don't know if you guys remember hyperbolic identities, but this right here, you should be able to know. We have cos squared x minus sinh squared x is equal to 1. So this right here will give me 1 over cos squared x. And what is 1 over cos x? 1 over cos is the same as sec hyperbolic. So 1 over cos squared is the same as sec hyperbolic squared x. So these are things you're supposed to recall from like hyperbolic identity, hyperbolic functions, the topic hyperbolic functions, guys, these identities. So that's it. That's how you go about differentiating some of these hyperbolic functions, guys. So they're not hard, and they're also in the table. So you can either express them in their exponential form, and if it's probably a tan, sec, ama cosec, you can be able to break them down into their different sine and cos, and then evaluate either using product rule or quotient rule, depending on how exactly they've been expressed. Okay, guys, so I would like for us to look at the last thing. I don't know if we still have enough time, but at least maybe we'll be able to do a few examples. So Finally, I want us to look at differentiation of inverse trigonometric and hyperbolic functions. There's a whole table on that, so you can be able to draw it. Differentiation of inverse trigonometric and hyperbolic functions. So how do you go about differentiating inverse trigonometric and hyperbolic functions? Guys, I'm advising you guys on the John Bird on page 334, there's a table on the inverses. Please take your time to like draw that table. I would want to show you how exactly to go about the differentiation of, let's say, cos inverse. Let's say you're told y is equal to cos inverse x, and then you're being told differentiate or get dy dx. How do you go about this, guys? Now, in order for you to differentiate these inverse functions, first of all, come and write them in their correct form, like cross the bracket so that it's no longer inverse. So this crossing to this side, we will have cos y is equal to x. Then differentiate. What is the derivative of cos y? If you differentiate cos y, you will get minus sin y, don't forget dy dx, is equal to, if you differentiate x, you get 1. So make dy dx the subject of the formula. Dy dx is equal to 1 over minus sin y. This is the answer, guys. However, our question was given in terms of x. So I would want to write this back in terms of x. Come and look at this relationship here. X is written in terms of cos. So I'm looking for a relationship between cos and sine so that I can be able to write sine in terms of cos. From the identities, we have this identity that says cos squared theta plus sine squared theta is equal to 1. This is from the SMP, and this is under trigonometry. So what is sine theta from this? If you make sine theta the subject of the formula, it is the same as 1 minus cos squared theta square root, such that now our dy dx will be equal to 1 over minus, instead of sine y, we will have the square root of 1 minus sine squared y. And this gives 1 over the square root of 1 minus, sorry, not sine squared y, cos squared y. So we have like 10 minutes to go. I hope you're going to get this, cos squared y. Now guys, cos y is x. So cos squared y will be x squared. So this right here is the derivative of cos inverse. You can write it as minus 1 over 1 minus x squared square root. That's it, guys. So when you're being told to differentiate any inverse function, that's the process, that's the procedure you're supposed to go through. Let's say, let's take up another example. You're told y is equal to sine inverse x, differentiate. Bring this to this other side, we will have sine y is equal to x. Then go on, carry out the differentiation. If you differentiate sine y, you get cos y dy dx is equal to 1. Make dy dx the subject of the formula. So we have dy dx is equal to 1 over cos y. We already have our answer, but we need to write this in terms of x. And come look at this relationship here. X is equal to sine y. So what is the relationship between sine and cos? Cos squared theta plus sine squared theta is equal to 1. If you make cos theta the subject of the formula, then it is 1 minus sine squared theta square root. So this is from trigonometry. So our dy dx is the same as, oops. Our dy dx is the same as 1 over cos y, and that is cos y is the same as 1 minus sine squared y. But what is sine y? Sine y is x. So dy dx is equal to 1 over 1 minus x squared square root. So basically that's how you go about differentiating inverse trigonometric functions. I want to look at one last example of inverse hyperbolic functions, and then you guys can be able to now do the exercises on that. That is exercise 136 and exercise, that is exercise 136, yeah? And exercise 137. Exercise 136, exercise 137 from the John Bird. Okay. So let's look at the third example. Let's say you're told y is equal to sinh sine hyperbolic x. How do you go about differentiating that? So the procedure is more or less the same. Bring sinh to this other side. So we'll have sine hyperbolic y is equal to x. Differentiate sinh, you get cos y, don't forget, dy dx is equal to 1. Make dy dx the subject of the formula. You have dy dx is equal to 1 over cos y. So you already have your answer, but you need to write it in terms of x. So come and look at this relationship here. X is related to sinh y. So I will look for a relationship between sinh and cos. From the hyperbolic identities, cos squared theta minus sinh squared theta is equal to 1. I know probably you guys can't remember this, but you should. So making cos theta the subject of the formula, this is the same as 1 plus sinh squared theta square root. So our dy dx will be equal to 1 over, writing cos in terms of sinh is the same as 1 plus sinh squared y, because this was cos y, square root. So our final answer is 1 over the square root of 1 plus, instead of sinh squared y, we will write x squared. And that is how you differentiate inverse hyperbolic function, guys. So if there's anyone with a question, I'll take up the questions right now.